Hi everyone, good morning, good afternoon, good evening, depending on where you're joining us. Welcome to this webinar in the Kubernetes series, cube.live. This time I'm very excited to bring you Spinnaker on Kubernetes. So if you have been following my webinars, I've been covering basic to advanced concepts, and we are now entering one of the very exciting phases where I'm going to cover some of the upcoming emerging technologies in the Kubernetes ecosystem. And Spinnaker is one of those tools that is very well aligned with the principles and the philosophy of Kubernetes and cloud native computing. So those of you who are attending this for the first time, let me spend a minute introducing myself. My name is Janakiram. I'm based out of Hyderabad in India. I'm a Google developer expert on cloud and a certified Kubernetes administrator. I have about 18 years of experience, predominantly spent at Microsoft and AWS, and for the last 5 years, I have been on my own. I'm currently an advisor and an analyst focused on cloud native computing and Internet of Things. So let's get started. We have a pretty packed agenda for the day. I'm going to walk you through a variety of concepts. We'll get started with what is Spinnaker, because this is something that is evolving. So I want to spend a minute setting the stage on what exactly is Spinnaker. And then we'll take a closer look at the terminology related to Spinnaker. I'll also walk you through the installation process. This is something very unique, and I have had a couple of experiences, and particularly not so pleasant experiences of running Spinnaker in VMs and cloud environments, but it has become extremely simple to run Spinnaker on Kubernetes. So I'm going to walk you through those steps, and then we have the most exciting part where we'll configure complex pipelines, and I'll show you how to perform blue-green or red-black deployments using Spinnaker on Kubernetes. So that is going to be our continuous delivery pipeline. So let's get started with what is Spinnaker. If you are familiar with Netflix open source ecosystem, I'm sure you would have heard of something called Asgard. And Asgard has been a very powerful and a popular tool in the open source community. A lot of AWS customers have used Asgard for automating the process of building AMIs, deploying, scaling, and managing them. So Spinnaker is essentially a successor to Asgard. It is far more streamlined and far more multi-cloud than what Asgard has been. Asgard was predominantly an AWS tool, whereas Spinnaker is targeted at multiple clouds. So it's an open source, multi-cloud continuous delivery platform built by Netflix as a successor to Asgard. The biggest advantage of Spinnaker is it enables repeatable automated deployments with configurable and very flexible pipelines. So you can actually take the pipelines that you configure in Spinnaker, export them and import them in other Spinnaker deployments and repeat exactly the same type of deployment. So it's very portable, it's very extensible. At the same time, it is very configurable. Once you start using Spinnaker, you never have to deal with individual clouds or individual mechanisms of creating load balancers, creating firewall rules, or dealing with the gold images. All of that will be consolidated into Spinnaker because it provides you a global view of the entire environment. So you can create pretty sophisticated deployment pipelines that span multiple cloud environments. Currently, Spinnaker supports, of course, Kubernetes, AWS, Azure, GCP, and OpenStack. Other platforms are coming. For example, I have seen support for Heroku, Google App Engine, and even other PaaS environments, Cloud Foundry, and so on. So Spinnaker will only grow in terms of its ability to target multiple cloud environments. But as of now, the most popular choices are obviously Kubernetes, AWS, Azure, GCP, and OpenStack. So what can you do with Spinnaker? I have been in the business of managed services and DevOps for a few years. And when I first saw Spinnaker, I was blown away by its power and its flexibility. So what it lets you do is to target multi-cloud deployments with a lot of ease. Without Spinnaker, targeting multiple clouds is going to be very challenging. So here with Spinnaker, You have a common taxonomy, you have a common terminology, you have a common view. I don't want to use the term single pane of glass. It's one of the most abused terms in the management space of cloud and DevOps, but it does provide you much more than a single pane of glass. It gives you a global view from which you can very easily target multiple deployment environments from Kubernetes to AWS and so on. You never have to log into the management console of cloud provider. You never have to deal with individual cloud provider environments or cloud platforms. You can create extremely complex deployment pipelines. If you think Jenkins is very powerful, this takes Jenkins to the next level because it integrates very well with GitHub, Jenkins, Docker Hub, and a variety of cloud platforms, and it augments Jenkins by delivering more sophisticated and more controlled pipelines. With Spinnaker, you can start with a few instances and scale to hundreds in just a few minutes. It's a very powerful deployment tool. It is not really meant to manage post-deployment because Spinnaker believes in immutable infrastructure. You are not expected to SSH into any of the instances that Spinnaker deploys, but you can reconfigure your pipelines very quickly and scale from just a few instances to hundreds in a few minutes. If you have heard of blue-green deployments, Spinnaker just makes it a breeze. Performing blue-green deployments has never been so simple and so easier. And canary deployments, where you can basically bring multiple versions, define a policy to target different versions and carefully monitor in a very controlled environment, you can do that. And that's what is called the canary deployment. And as I emphasized earlier, all of this will be done with just the Spinnaker interface without ever dealing with individual deployment targets or individual cloud environments. So let's spend a minute understanding the terminology. So once you start dealing with Spinnaker, you will encounter some common familiar terminology, but it is slightly different. Particularly when it comes to Kubernetes, you will find Spinnaker terminology is slightly different, and it is important for us to map those terminology and the taxonomy with that of Kubernetes. So you will deal with an application. Application is essentially a collection of various resources. It ranges from creating load balancers to security groups to a server farm or a server group to clusters. It also contains various pipelines, various strategies. So think of application as a boundary. And then there is a cluster. A cluster is essentially a collection of server groups. And a server group is basically an environment. For example, you can have a different version of applications targeting a different server group. So for example, there could be a dev cluster, and the dev cluster can have multiple server groups. And each server group within that cluster could represent a different version, a different build coming from either an AMI build process or a Docker Hub image. So a server group is nothing but a collection of stateless instances. In AWS, if you're familiar with it, think of it as an ASG, an auto-scaling group. In Kubernetes, a server group is essentially a set of, it's basically a replica set. And a cluster is nothing but a deployment, if you are familiar with Kubernetes terminology. Load balancer is a load balancer. If you're dealing with a cloud, it's a straight mapping from the ELB or Azure load balancer or GCP load balancer. But when it comes to Kubernetes, interestingly, the load balancer is going to be the service. So it is going to be either a cluster IP or a node port or a load balancer. It can be any of those. And security group is basically a firewall. If you're dealing with a cloud provider, this is a straight mapping with the firewall rules or the security group rules. But when it comes to Kubernetes, a security group in Spinnaker maps to an ingress, because technically an ingress is the rule engine that is going to forward the traffic to different endpoints. So security group translates to an ingress. Pipeline is very native to Spinnaker. It is where the action takes place. So you will create multiple stages as a part of pipeline. For example, pull the latest image out of Docker Hub, and deploy that into a server group. And as soon as the health check is performed, you go ahead and destroy the previous version. So all of those are different stages, and you assemble those stages as a pipeline. And of course, I'm going to show you a live demo of this. Strategy is a very powerful concept. This will basically help you define how your deployment takes place. For example, if you want to perform canary deployment, you can say, leave my V2 and deploy the same number of instances running V3. So route 50% of traffic to V2 and 50% of traffic to V3. That is a strategy. Or you could actually say, as soon as V3 is deployed and the health check becomes green, go ahead and destroy V2. That is another strategy. So a strategy is a very powerful concept in Spinnaker, which will define how your deployment takes place and what are the steps it will take once the deployment is successful. So pipelines and strategies work like hand in glove. They are a combination that will give you a very sophisticated deployment mechanism. So that's about the terminology. I'm going to revisit this when we start the demo, but it's important for me to set the stage by mapping these concepts with Kubernetes. So how do you install Spinnaker? Let me tell you, I have about 6 months of experience dealing with Spinnaker. I helped a customer deploy that in production, and it was a nightmare, particularly if you're not using one of the resource manager template in Azure, or a deployment manager template in GCP, or a CloudFormation in AWS. If you're not using that and you want to understand Spinnaker by installing everything from the scratch by hand, it's a nightmare. And 8 out of 10 times your installation will not go through because it's too fragile, and there are way too many tools, very sparse documentation. You have to tinker with something called Halyard and use that to basically configure a variety of components that make up Spinnaker. The interesting fact is Spinnaker in itself is a microservices application. So it obviously comes as a set of containers, or if you're actually running it on Ubuntu, it is coming as a set of Debian packages. So getting the right version, assembling them, and making sure that it is working is a pain. And it's been a pretty difficult task so far. But I'm so much thankful to the Helm community for creating a Helm chart for Kubernetes, and it has dramatically reduced the effort and just took away the pain of running Spinnaker. You don't believe it is just 3 commands that you need to basically get up and running with Spinnaker, and it can't get simpler than this. I was so thrilled, so excited, and I can't thank Helm community enough for making this happen. It's a chart, so you can basically grab it and install, and in about 20 minutes, depending on your bandwidth and the power of your cluster, you'll have a full-blown Spinnaker deployment up and running. To achieve the same, I spent days and sometimes weeks to get it up and running. So how do you install Spinnaker? Very simple. First, grab Helm from GitHub, get the latest release, then initialize it. Helm init will basically run what is called a stiller, which is the server-side component of Helm. It is going to be installed inside Kubernetes cluster, listens on a specific service endpoint. Once you have Helm up and running, then you grab the Spinnaker chart and install it. For example, Helm install -n is the name of the chart, the deployment, and we are getting the stable version of Spinnaker, and that's it. These 3 commands will get Spinnaker completely configured on any powerful Kubernetes cluster. The interesting fact is I have managed to run Spinnaker on Minikube, but there are some minute changes that you need to do. For example, when you're launching Minikube VM, make sure you give at least 8 GB of memory to it, because Spinnaker is a very powerful, at the same time, it's a bloated piece of software because it comes with many containers and very resource heavy components. So make sure that your Minikube or the cluster is powerful enough to run Spinnaker. So that's it. This is going to get you access to Spinnaker. So without further ado, let me show you what it takes for us to actually get Spinnaker up and running. I hope you're able to follow this. Let me make sure there are no issues. Let me take a look at the questions. Okay, looks like there has been some problem with the screen sharing. All of you should be able to see it. So let me just do a quick recap of what I have shown you. This is certainly a screencast, but there has been some problem. So I have just stopped and started the screen sharing. So you should all be able to see this. So I talked about installing Spinnaker. So this is how you will basically get started with Spinnaker on Kubernetes. So you haven't missed much because there have just been a couple of slides. And sorry about the technical glitch of not showing the screen. I don't know what went wrong. I had to just stop and restart the screen sharing. All right. So now I hope all of you are able to see the screen. Awesome. Excellent. So now let me show you. I have, first of all, let me give you a glimpse of my Kubernetes environment. So I'm currently running this in GKE with slightly powerful configuration. I'm not using standard N1. I'm actually using the next configuration that gets me 7.5 GB of RAM with 4 cores. So this is my simple 2-node GKE cluster. And I've already gone ahead and installed Helm. So once you install, it's a single line installation, so single command installation. So I'm not showing you how to install Helm. It's a pretty straightforward, no-brainer installation. But make sure you have the tiller running in the backend in the Kubernetes cluster. So Helm version will make sure that your Helm installation is perfect because you can actually see the client and the server version. So with this in place, all you need to do is run a single command, which is the Helm chart install command. So this is the Helm install, give a name, and then run Spinnaker from the stable build. And there is a configuration file. So here is the configuration file where you can basically associate your Spinnaker deployment with your Docker Hub account, particularly if you want to perform automated deployments all the way from GitHub to Docker to Spinnaker. You need to customize this. So you need to give your Docker Hub username, password, and the repositories that you want to pull straight out of Spinnaker. So there are not many changes that you need to make except the Docker Hub configuration. So once you have that configuration file, you basically mention what version and install Spinnaker in a different namespace. So here I have given the namespace of Spinnaker, but it can be anything. So how do you ensure that Spinnaker is installed? Well, you need to get all the pods for the namespace Spinnaker, which I have given during the creation of the chart. So this is going to show us a bunch of pods up and running. So this is like my dream come true because I struggled so hard to get to this point, but with just one command, I'm able to get everything running. So you'll see that there is a cloud driver. Basically, cloud driver is the component responsible for Spinnaker to interface with multiple deployment targets like Kubernetes and AWS. Deck is the front end. This is where the actual UX runs. There are multiple other microservices that are composed into Spinnaker. So there is friend, there is gate, there is Igor, Orca, Roscoe. All of them are essentially containers that map to a microservice. Apart from that, Spinnaker uses Redis for the cache and the store. Minio is used to store the artifacts. If you are running it in the cloud environment, this obviously maps to Google Cloud Storage or S3. And there is a Jenkins integration as well. So you can basically run Jenkins as a part of Spinnaker. But I'm not going to touch Jenkins here. It is out of the scope, but I'm going to show you source code to production from GitHub to Docker Hub to Spinnaker to Kubernetes cluster. So this is an indication that we have the Spinnaker installation perfectly set up. Further, what I'm going to do is expose one of the pods to localhost. So if you're familiar with this command, which is the kubectl port forward, I'm going to run that. For that, we need to grab the pod name of deck. So this is going to help us get that. So we are actually trying to find out what is the pod name that is randomly assigned by the Helm chart by using the JSON path. So this is going to get us the name of the pod responsible for running deck. So this is the one. After that, all we got to do is expose this pod on port 9000 on the local host, because interestingly, you cannot run Spinnaker on port 80. You can't directly expose it on an ELB or an ingress because it's too sensitive. Currently, Spinnaker is not very secure. It doesn't have authentication. It doesn't have any of the security gates. So you got to be very careful when you are exposing Spinnaker to the outside world, because if someone gains access to Spinnaker, they can pretty much spin up anything in your environment. So that's the reason why Spinnaker is always accessed through port forward. This is the best way, because you have a tunnel into the Spinnaker deployment without really exposing it to the outside world. So let's go ahead and run this. So this is now going to expose the UX of Spinnaker, which is available in deck pod, and it's going to be made available to us on localhost 9000. So this is going to show us the UX. If you're expecting a very jazzy UI, you will be disappointed, but don't underestimate Spinnaker by looking at the UI. This might look very, very simple, but it is actually very misleading. You know, when you look at the power of Spinnaker, you will understand why it has been so simple. So, so this is basically making sure that everything is configured properly. So we first installed Helm, then we installed the Spinnaker chat, and then we grabbed the pod, exposed it through the port forwarding mechanism, and now we are able to access Spinnaker through the localhost 9000 port. Perfect. So this is the first step where you actually get Spinnaker up and running. After that, I want to show you how things work. So this is where it gets extremely interesting. So now I'm going to show you two things. Okay, so let me stop this and use manual forward. So basically the goal is very simple. I have a GitHub repo with two branches. The master branch is the production environment. The dev branch is my staging or dev environment. And these branches are picked up by Docker Hub, and it basically builds two images in Docker Hub. The latest tag corresponds to the master branch. The dev tag of the image corresponds to the development branch. We are then going to pull the images into Spinnaker by creating two different pipelines, and eventually we will merge these pipelines, or rather we'll take the output of the dev pipeline, perform a UAT on it, and if everything goes through, we basically move the dev pipeline into production. So in that process, we'll actually do, we can do a canary deployment, we can do blue-green deployment. It's completely up to us. So I'm going to walk you through the entire process of building a pipeline. So this is going to be pretty interesting. And this is where the rubber meets the road. You know, it all starts to make sense when you actually see the demo. But before that, let me give you a quick sense of the app that we're going to deploy, because everything lies in the way we are going to deploy an app. So you need to understand that. So this is my GitHub repo. I have a very simple application. I call it simple app. The idea is not to overwhelm you with a very sophisticated microservices cloud native app. Instead, this is basically an Nginx app with a static HTML page, but it doesn't matter. You can basically take any app and move it through the Spinnaker pipeline. So this is my master branch. I have a dev branch, and as I mentioned, dev represents my green deployment and master represents my blue deployment. So these two are built into two different images. So let me show you how this application looks like. So let me first run the blue deployment, which is the latest. So I'm actually running the blue deployment pointing to the simple app latest, which is pointing to my GitHub master branch. So when I actually run this, so and hit localhost, you'll actually see this is V1 of my application. And to make this very clear, I put the background as blue. So this is my V1. So let me kill this and run my next image, which is actually built out of my dev branch, and this represents my green deployment. So when I do a refresh, you'll actually see v2 of my web app. So two different images corresponding to two different branches, and our goal is to basically start with v1, go live with it, then test v2, perform a UAT, and if the test passes, promote v2 to production and kill v1 and completely productionize the latest version. So that is what we're going to achieve at the end of this demo. So let's get started. The very first thing is to go ahead and create an application. So you'll actually notice that Spinnaker is picking up the existing deployments and the existing namespaces here. These are not configured. Actually, I could filter them. I can hide them by pointing Spinnaker only to the default namespace, but I didn't do it. So don't get confused by looking at these names. They are basically what we have as deployments in our current cluster. So I start by creating a new application. So let me call this Cube Live. Oh, it's already there. So we'll call this Cube Demo and give a email ID. Everything else is optional. So we are now creating a boundary for all our resources and our deployments. So once we create this will not translate into anything. At this point, an application is just a Spinnaker logical boundary. It doesn't really map to any cloud resource or a Kubernetes resource. So this is the blank slate. We don't have anything configured. So let's start by load balancers, right? So I want to first create a load balancer through which our production application will be exposed. So we're going to create a production load balancer and eventually deploy the pods that will be mapped to this load balancer. Behind the scenes, it is nothing but creating an association between the service and the pods with the labels and selectors. So let me click on this and create a new load balancer. So the stack, I'm going to call this prod. So this is a production stack. And this is going to be exposed on port 80. The target port behind the scenes, the backend port on the pods is also going to be 80. I want to, if you actually notice when I ran the Docker containers, I just exposed it on port 80. So no change that needs to be done here. And once you define the port mapping, you need to define what kind of service you're exposing through Kubernetes. Obviously, you'll see cluster IP, load balancer, and node port. So I'm going to choose load balancer because we are going to expose this to the outside world. If you want, you can also give a hardwired node port to which the load balancer will automatically configure, but I'm just leaving it dynamic. That's it. We are now done with the basic settings. So we are now identifying this as production. This is just a label. So the core naming components of a cluster. So we are calling this prod because this is going to be a label that we'll assign to all the resources that will eventually target production. And then we define the port of type load balancer, and we'll go ahead and create this. While this is creating, let's come back to the command prompt and check the services. So you'll actually notice that Cube Demo prod, the load balancer that we created actually translates to a Kubernetes service. So you'll actually see that this is pending. So Cube Demo prod, it has taken the application name, it has taken the environment name, and type is load balancer. This is pending, obviously, because GCP will take a while to create a load balancer and assign it to this. So it is going to be pointing to the node port, which is randomly picked up, and there we go. So now this is assigned, perfect. So I can actually grab this external IP, right, and access this here. So obviously this will not show us anything. We just created an empty service with no pods behind the scenes, so it's not going to show us anything. So let's leave it as it is, come back to our Spinnaker environment. So now this is our first load balancer, and we are all set to expose our deployment via this production load balancer. All right. Now the next step, I'm not going to configure ingress, so no security groups. I want to keep this simple. So I'm going to come to the clusters and create our first cluster. Okay, so the cluster is nothing but a collection of server groups. So for all practical purposes, this is almost like a deployment, and this is going to be mapped to a set of replica sets. So pretty straightforward. So we are going to associate the load balancer we created earlier by calling this stack prod, and this is going to be almost analogous to the label selector concept of Kubernetes, but this is very specific to Spinnaker. So we assign prod as this stack, and we need to mention what is the container that we're going to pull from Docker Hub for deploying the production app. So the moment I type simple app, it shows us two different images with two different tags. Obviously, I don't want to use dev, that is saved for our A/B testing and our staging environment. So I'm going to pick latest. This is what I want to push to the production. If you want to really configure this as a deployment, click on this, but that's completely optional. This is where you will associate this server group with load balancer. So kubedemo prod is what we created earlier, and now we are associating this. If you want, you can enable horizontal pod auto scaling, pretty powerful, but I'm not going to do that. Instead, I'm going to launch 4 pods as a part of the replica set. So if you actually see, all this corresponds to creating a deployment with the number of replica sets, the desired count, all of that. So it indirectly maps to that. Then I need to basically, let's give a name to our container. I'm going to call this blue. And the pull policy is always, because as soon as we build a new container, container image, I want Spinnaker to build it, so pull it. So even if it is present, I want this to pull the latest image from Docker Hub. And finally, we'll enable a readiness prop. This is important because this will define the health of our deployment. And since our pod listens on port 80, we need not change anything here. So our Nginx default homepage is available on the root. So nothing needs to be done here. We are all set. Just to do a quick recap, I'm basically giving the stack name as prod, associating that with the simple app latest, the production container image, associating that with the load balancer that we created earlier, and we are manually launching 4 pods as a part of the deployment, and we have gone ahead and created a readiness prop. That's it. So now we can create this server group, and while this is being done, let's come back and put the kubectl get pods in watch. So you'll actually notice that this is now turning into a replica set with 4 pods, and there is a naming convention. So kubedemo is the application name, prod is the stack, v000 is the version, the first deployment, and these are the arbitrary names that are assigned by the deployment or the replica set. Now everything is up and running. Let's come back to our load balancer and do a refresh. There we go. Now we have the production app deployed on the Kubernetes cluster completely from Spinnaker. And now you'll actually notice that this represents 4 blocks, which essentially translates to the 4 pods or the 4 instances of the deployment. And that is associated with the load balancer kubedemo prod. Perfect. So this is how you basically deploy apps from Spinnaker. But this is not complete. This is a great start where we are able to connect the dots and perform a deployment. But we want to go beyond this. We really want to create sophisticated pipelines which are more automated. So let's go ahead and do that. For that, we need to start with another load balancer, and this load balancer is going to be our dev environment. So I'm going to create another load balancer. Let's call this dev. Everything remains the same, except that I'm not going to associate this to a load balancer. Instead, we'll leave it as cluster IP, because I want this to be available internally to select set of users. So I'm not going to expose this service to the outside world. So obviously we're going to leave cluster IP as it is, and we'll go ahead and create this. So this will basically translate into another load balancer, right? If you look at the get service thing, you'll notice that our dev load balancer is nothing but a cluster IP with no external IP. Perfect. So now we have two load balancers. One is pointing to the production, the other one is pointing to dev. This is actually an external load balancer. This is a cluster IP. All right. Now we'll come to clusters, but we are not going to create a cluster manually. Instead, I want to introduce you to the pipeline concept. Now the goal is to deploy the dev environment with one commit. So the workflow will be something like this. So the way I'm going to do this is my dev. When I actually make a change to my source code repo in GitHub, this is already configured to talk to Docker Hub. So if you actually look at integrations and services, I have already configured this to trigger a Docker Hub build process. So I have already connected Docker Hub with my GitHub repo. So this is where the magic happens. So in the build settings, I have already connected the branches. So master branch will be built into a Docker image with the tag latest. Any change made to dev will result in a new Docker image with the tag dev. So pretty straightforward, and the complete webhook integration is done, which means the moment I make a change to my repo, it will automatically trigger a build process in Docker Hub. So that's what we want to achieve. Now, before we get there, let's actually do a pipeline. So you notice that 8 hours ago, I already built the latest and the dev images. So that's already in place. Before we make any changes and trigger the automated workflow, I want to create my dev environment. So we come to pipelines, and this is where the magic begins. So pipeline is essentially a collection of stages, and every stage is responsible for a very well-defined action. So I'm going to create a pipeline, and let's call this deploy dev. So that is the pipeline name, and we need to configure this pipeline with multiple stages. So there is configuration, that is the starting point of the pipeline. This can be automated. So you can click on automated trigger. There are multiple triggers. You can actually trigger from Git. You can trigger from your CI/CD environments like Jenkins, Travis, or another pipeline, which will result in triggering this pipeline. But for now, we are going to configure Docker registry, right? So this is already, because I have configured Spinnaker to talk to my Docker Hub account, you will notice that it automatically picks up my username, and it picks up the image as well. So tag, I'm going to leave it empty because I want this to be triggered irrespective of the change in dev or production. So we're going to leave this empty. Otherwise, you can also give a regex expression here, and this regex expression will be used to decide whether Spinnaker will pull the latest image or not. So we're going to save this. That's the very first stage of our pipeline. Then we're going to create another stage, and obviously this stage is going to be called as deploy. So there are multiple stages. We are going to explore some of them in the coming steps, but at this point we are going to deploy the dev environment. So I choose deploy, and here we are going to create a deployment configuration. So basically what we are saying is, the moment you get a new image from Docker Hub, go ahead and create a new server group. So instead of repeating the entire story, you can copy prod and modify it to an extent that is applicable. So what I'm doing now is I'm picking up the existing server group, which is Kubernetes prod, kubedemo prod, which we configured manually in the previous step. We are going to use that as the template and modify a few things. So the very first thing is change this to dev, because we want to target the dev environment, and eventually this will be exposed via the dev load balancer. Get rid of this. We don't want the latest Docker image. Instead, we want the dev version of the Docker image. Strategy, right? I'll come to it in a second, but for now I'm going to choose none. Okay, everything else remains the same. For example, get rid of production load balancer here and point this to the dev load balancer, because we want to do a UAT test before we go ahead and promote this to production. And when it comes to containers, obviously we want to call this green, and always pull the image all the time, even if the image is already there. So this is pointed to dev because we have defined it here. We'll also make sure that the readiness prob is in place. Perfect. So what we have done now is we have modified, or we have copied and pasted the production server group and made some changes, essentially replaced prod with dev and pointed this to the dev load balancer. And of course, the image is now pointing to dev, and it's going to be called as green because it's a green deployment. And click on add. Pretty straightforward. So now we have a two-stage pipeline. And what does it do? The first stage is it's going to pick from Docker Hub. The moment the image is pulled, it moves to the next phase, the next stage of the pipeline. And here we are going to deploy that image to a dev environment. And this dev environment will be eventually become available on a cluster IP, which we're going to test. All right. So now we are here. Again, there is a catch here. For some reason, I'm unable to get the automated trigger to work. Ideally, whenever there is a new Docker build that takes place, the pipeline should automatically execute. But I'm not sure where I'm going wrong, but I couldn't get this running. So I'm going to kick off this pipeline manually. But the process remains the same. It's just that we don't see that magical triggering every time we commit the source code. But this is a matter of time before it gets fixed. So for now, what I'm going to do is kick off a manual execution. And this manual execution, we choose deploy to dev, tag is dev, run. So this is going to perform the two phases, right? Of course, configuration we have bypassed by clicking on the manual execution. Now we are actually going to see that this pipeline is going to be deploying our dev environment. So it will become very interesting when we start watching the pods. So now you'll actually notice that we'll have 8 pods running, 4 in production running V1, and we deployed it 10 minutes ago. The dev environment is running the latest image for 34 seconds, right? And now how do we access this? Because this is a cluster IP. So there is a technique for that. What I'm going to do is run kubectl proxy to open up a tunnel to the Kubernetes cluster, and then simply open this URL. So I switch to other browser, and when I actually run this, there we go. So now this is V2 of the web application deployed via our pipeline. So now the cluster is running 2 different environments. V2 in a very obscure dev mode, and V1, which is available to the outside world on the public IP address. Our goal is to promote V2 to V1 and make that as our production environment. All right, so let's come back And this is all green, which means the pipeline has succeeded. Perfect. Now what we're going to do is to modify this pipeline a little bit. So now what I want to do is actually push another build, and this time I'm going to trigger this automatically till the Docker hub, and we'll trigger the process manually here, but it's going to be very seamless. So for that, what I'm going to do is I'm going to add another stage, and this stage, what it basically does is it destroys the previous server group. So what it means is, let's say we push v3 and v2 is already running here. What we want to do is destroy the previous version after the current version becomes available. That means when we push v3 to the dev environment, the health check passes, the health probe is all green, and when this happens, we'll basically destroy the previous server group, which is v2. So that's what I'm going to configure now, because we're actually going to push v3. So what we'll actually do here is choose the cluster. Okay, in the namespace default. So choose dev cluster, and we'll actually say previous server group. You know, what do you want to destroy? So we want to destroy the previous server group, whatever was deployed, and typically this is going to be the previous version that is hanging around in the dev environment. So we don't want to have that anymore. As soon as the new version is deployed to dev, we want to go ahead and destroy the previous version. So that's what I'm configuring it here. Okay. That's it. So this is the only change I want to make. So that is done. Now we have this pipeline, and I can delete the previous execution, it doesn't matter. Now what I want to do is to create another pipeline, and this pipeline is going to be a manual verification pipeline. What it means is, let's say we push v3 to dev, we invite some testers, and all of them give it a go ahead. Then we'll actually click on a button, and that will trigger another pipeline which will push v3 to production. That's exactly what we want to achieve with this. So let's go ahead and create another pipeline, right? And let me make sure all of you are with me. And okay, so there are no issues in the chat window or the question box. So looks like everything is fine. So let me go ahead and create another pipeline. So so we are going to call this UAT, right? So that is the user acceptance test. Let's create this, and here in the configuration, the automated trigger is not going to come from the outside world. Instead, it comes from the previous pipeline. So we choose the pipeline here, and deploy to dev is the pipeline. The success of deploy to dev will trigger the UAT, right? So that's what we do here. Let me save this and then add another stage. So when it comes to new stage, there is something called a manual judgment. So manual judgment is where you'll actually click a push button to manually approve a build, which will trigger the remaining workflow. So we are now going to say approve, right, or reject. So these are the two push buttons that I want to expose. So we'll also provide instructions. So we'll say approve or reject based on the UAT feedback, right? That's the prompt to the DevOps engineer or the release manager who is responsible for promoting this build, this release to the next pipeline, right? That's it. So we don't have anything else to do here. Basically, we are pausing the process to make sure that we have a manual phase, right? So now the version gets deployed to dev, then it moves to UAT phase, and if UAT passes through, we'll promote to prod. So let's go ahead and create another pipeline, and we are going to call this promote to prod, right? So this is the final step where we'll push the latest version to the production after sufficient testing is done and a manual justification is being made, right? So we come to configuration and we will again say trigger this after the manual UAT is done. So we'll now say trigger this based on the success of UAT feedback, right? So that is the first step. Then we're going to add a stage, and obviously this is deploy. So we are going to now deploy this directly to prod. So you'll notice that it is showing us two, because one is dev, one is prod. So we'll choose prod, and we need not even make any changes because everything is just perfect, except that we need to choose the dev version, because that's what we are promoting, to production. So we will actually, this is not the best strategy. You should have a version attached to the tag, and that should correspond to the build. But because we are using just two builds, I have gone ahead and put this dev and latest for simplicity. But in production, ideally this should be mapped to a release tag, right? So strategy, what does this mean? So what happens when your deployment takes place? So there are multiple strategies. Highlander is a strategy where it destroys all the previous server groups and promotes the latest deployment as the primary. As soon as the health check passes, it basically destroys everything else in the server group. Sometimes this is what you need. None is, it is going to leave whatever is running in the production server group as it is. This is very good if you're actually doing canary releases. For example, there are 4 pods running V1, and now you are pushing another 4 pods running V3, and you have chosen none as the strategy. That means you'll end up running 8 pods with 50-50 of V1 and V2 or V3. So your traffic will be automatically distributed, and you can start monitoring them, and eventually you can promote the latest version into production. So that is, when you want to implement canary, you can choose none. Red black is basically blue green. What it does is it doesn't destroy, but it disables the previous server group. Because in blue green, if for example your green deployment fails miserably, you want to quickly roll back and point everything to blue. So that's exactly what happens with red black strategy. So strategy is a very powerful one, and if you don't like the Highlander, none, and red black, you can define a custom deployment strategy. For example, you can mention what is the percentage of instances you want to mix and match, and you can also write custom plugins to take care of your strategy. It's a very advanced concept, but the good news is this is possible, and there are companies building solid analytics and plugins to enable canary deploys based on the custom strategy. Now I'm going to choose Highlander. And Highlander is basically destroy everything else, right? So obviously we are targeting prod. We'll come down to the container. This is dev, always pull, even if it is there. Then enable readiness probe, because this is very essential for the health check to pass. That's it. So now we have the stage defined. Now that's not all. Now I want to do one more thing. Once the latest version is deployed in production, I want to go ahead and kill everything else in the dev environment, because I don't want the dev environment to hang around. Imagine in EC2, running 4 EC2 instances is an expense, right? Particularly on those stale dev machines, dev environment. So you never want them to run anymore. So now what we'll actually choose is destroy server group. And what do we want to destroy? We basically want to go ahead and destroy the dev cluster, right? And we want to target the newest server group, whatever was there for us to test as dev. We want to go ahead and kill that completely and wipe off. So what this will ensure is ultimately we're going to end up having just 4 pods as a part of the replica set, as a part of the deployment, and that is our latest version. So we are now killing the dev environment without leaving any traces, because we don't want that to exist, and we want to free up all the resources. So we are almost done. We'll click on Save Changes and come back to the pipeline. So now our sophisticated pipeline is all configured, right? So first we deploy to dev, we perform a UAT test, we approve the UAT, and then we promote that to production and kill the dev environment. Everything sounds good. So it's time for me to actually trigger this. So what we'll do is we'll come to GitHub, access the dev branch and make a change, right? This is going to take a while, but bear with me. This is a very worthy demo. I was very excited when I finally got this to work. So I click on index.html and I make some changes, right? So let's actually call this as green, from yellow green to green, and we'll make this as v next. So this will be v next, right? And I'll call this as the v next update. So I'm making some changes to my dev repo, dev branch in the GitHub repo. And the moment I click on commit, this will trigger a build process in Docker Hub, because they are already connected via the webhook, and there we go. So now it has started the build process. So for some reason it has queued up more than one, but never mind, it doesn't really matter. So in a few minutes, we'll actually have the latest dev release with the changes that we made, right? So let's just wait for this to finish, depending on the load of Docker Hub, because I am on the free account. It's not prioritized. I have to wait till everything else is clear, and then this is going to kick off the build process. And the moment the build process is kicked off, ideally Spinnaker should start this, because we already configured that with Docker Hub, but that's not going to happen. I'm going to manually kick off this process, and eventually we'll promote this to prod, and we'll end up having vNext running in production. Meanwhile, let's come back and take a look at the pods, right? Obviously, there are 8 pods, 4 running the production environment, 4 running the dev environment. Now, when we actually launch vNext, for a moment, the dev environment will run 8 pods, basically v2 and vNext. And as soon as vNext is green, v2 will be destroyed. So that means we'll again end up having only 4 in the dev environment. And the moment the UAT passes and we promote the environment to production, even that will be completely wiped off, and we'll be finally left with kubedemo prod with just 4 pods, and that will reflect the vNext. That's the goal of this demo. So let's come back and check if Docker Hub has kicked off the build process. Not yet. This is the most tricky part of the demo. I am at the mercy of Docker. Okay, there we go. So now the build process has kicked off, and as you see, it's a pretty simple Docker image, nothing fancy. And in a few minutes, it should be done. So I'm just waiting for the build process to finish. The log should show that, yeah, there we go. So build finished. That means this is almost done. I'll also wait for this to say success, just to make sure that we are not bypassing anything here. And bear with me as I finish this process, but from there on, it is going to be on a fast track. So it'll be fun. Okay, perfect. So now the dev build is success. Let's come back to, actually, let me get rid of this. I don't need it. Okay, so now the magic begins, right? I'm going to start the execution of deploy to dev, right? And let's run this. So when this starts the pipeline, when the okay, so when I click on run, now it is going to kick off a manual trigger, and we'll actually notice that it's going to pull the latest dev release. Okay, and there we go. Now you'll actually notice that there are going to be multiple pods, particularly with this moniker of V001. That means dev environment is currently running vNext as well as V2, right? The previous one with light green and saying welcome to V2 of the app, that is still running, and the V next is also running. Now in a few minutes this will be completely wiped off, because remember we configured the pipeline in a fashion that as soon as the latest version is green, that is the health check passes, we go ahead and destroy the previous version. So in a few minutes, everything that has V000 will be completely gone, because V1 would be stabilized and everything will be green there. Okay, so interestingly, if you look at the cluster and the server group, you'll actually notice there will be two server groups. Okay, I'm just waiting for this to show up. It's going to take just a few minutes. So it hasn't reached the second part of the pipeline, which is destroy server group. So the first one is still executing. That's the reason why we notice that everything is still intact. But as soon as the progress moves to the other part of the, am I still connected? Because my Spinnaker is not refreshing. Okay, all right, so all right, okay, so there we go. Now we're actually seeing the second part of the pipeline getting executed. So now the pods which are running the previous version will automatically vanish. So it will, and they are terminated. So everything will be gone and we'll be left with the V next running in dev. Perfect, that's exactly what I wanted. Now it's time for us to wait for the manual thing to trigger. Okay, so now the judgment has to be given, but before I push that button, I want to make sure that our dev environment is running V next, and there we go, perfecto, right? So now our dev environment is running the latest release, which is the V next. So everything looks good. Now it's time for me to promote V next to V1, because this is still running the very old version, right? So because everything looks pretty good, I'm going to approve this and click on continue. The moment I click on continue, promote to prod will kick in. And this pipeline is responsible for promoting our vnext dev release to production. And here we go. So now UAT is done, and this is going to kick off the build process, actually the release process. So now you'll actually notice there are 8 pods in production, right? I'm not surprised, because 4 of them reflect the previous version, and the remaining 4 are what we promoted from dev to production. But as soon as they go live and as soon as the health check passes, because of our Highlander strategy, production will be reduced to just 4 pods. And not only that, we also instructed the pipeline to go ahead and destroy the dev server group. That means in a couple of minutes, we should be just left with 4 pods with a very clean production environment running the vnext and everything else getting wiped off. So let's wait for that to happen. So currently it is still waiting for the instances to become green. So if you actually come to the clusters, you'll notice that prod is running 2 different versions, right? So everything is green, but it will take a while to basically ensure that everything is up and running. So I hope you're able to follow this. This is our vnext, which is still running in dev. The V000 is reflecting the blue color, the blue release, the V1, and this is what we are actually running in the same cluster as a different server group, and both of them are pointed to the same, and here, it is disabled. So now it's getting terminated. When we come here, we should notice that prod environment should automatically get reduced to 4 pods with just the latest version running. So let's give it a minute. It's pretty risky to do a live demo, but I took the chance. The only side effect of that is the wait time involved, just staring at the terminal and the Spinnaker console, but it is worth, because as I mentioned earlier, I was pretty excited when I started to see this happening on my machine, because I have watched multiple videos and I always dreamt of making this work. So when I finally got this up and running in Minikube, running on my local machine, I was pretty excited, pretty thrilled. So let's wait for another couple of minutes. This server group should be completely destroyed. So here it actually shows that it's only 50%, because 50% is gone and remaining 50 is on. It also gives you a sense of how to do canary deploys. If I don't destroy this, you actually have a canary deploy, and you can pretty much route the traffic to the previous version and the current version, carefully monitor, and then run another pipeline that destroys this. Okay, so we are waiting for the second part of the pipeline to kickstart. There we go. So now the V1 of production is completely gone, right? And with that, we are also waiting for dev to get killed. While this is happening, let's take a chance, and I'm going to take a deep breath and do a refresh on my production. And perfect. This is exactly what I wanted to see. Welcome to the vNext of web application, and we have just done a hands-free continuous delivery thanks to Spinnaker, right? We are still left with this, but that will be gone. I think it's already gone. It is a matter of time before even the dev environment will be completely killed. So just wait for a while, and even the dev environment will be completely wiped off. And that is the desired state, where we have the latest version completely tested, trusted in production, right? So, and that's it. So now the dev environment running the stale dev version is also getting terminated, and we are now left with the clean production deployment with just 4 pods. Perfect. This is precisely the objective of this demo. And now we are all set to go live. Invite our customers to experience vNext, and the entire marketing kicks off. So that was the comprehensive pipeline management that I wanted to demonstrate. And though this looks pretty simple, I worked on this for about a week to get this to this point and to simplify the whole idea on the concept. Now, if you actually look at the clusters, do a refresh. Actually, dev cluster is completely gone because we don't need it. But the load balancer is still hanging around because eventually when we do another release, we'll utilize this to perform UAT, and everything else is still applicable. So the pipeline that we created is very reusable. We need not touch it next time when we do a vNext. For that, all I got to do is come back to GitHub, right? Make a change and commit, and everything else will be automatically triggered. Hopefully, Spinnaker will be able to pick up the trigger from Docker Hub and kick off the entire pipeline. So that is the comprehensive demo that I wanted to show you. And if you are experiencing this for the first time, I'm sure you will appreciate the power of Spinnaker. So before I take questions, it's poll time. I want you to tell me how you like this webinar. So appreciate your time and your feedback. So let me know what you feel about the relevance of the content. Great. I see some of you participating. I appreciate if everyone take a minute and participate in this poll. Great. Thank you. I have one final poll, which is a straight reflection on my style of delivery and the overall quality of the webinar. Again, I appreciate your feedback. Thank you. I only see 70% of you participating. If everyone can let us know what you feel about the quality of the webinar, that would tremendously help us. All right. So thank you once again. So let me quickly take a few questions. We're already running out of time. We have gone past 1 hour, but let me take up a few questions. So there is a question on templatizing the pipeline across an organization. Absolutely. One thing that I didn't show you is this. For example, when you have the pipeline, you can always click on source, and this actually shows you a JSON serialized way of your entire pipeline execution. And you can actually use this for porting your pipelines across multiple Spinnaker deployments. You can also script it completely. So the pipeline is not a black box. It is very configurable, very portable, and scriptable. So you can completely automate this, and you can standardize the way the pipelines are created across the organization. So there is a question on sharing the user guide for the installation. Actually, the user guide is pretty straightforward, as I have shown you earlier. It is just the 3 commands. You don't need anything else. And look up on the Helm repo on the steps to install the chart. That's it. Now, this is basically the user guide you need to install Spinnaker on a working Kubernetes cluster. How can we get the demo slides? I'm going to upload this to SlideShare. The video will be made available on YouTube, and all of you will receive a link after the webinar in a couple of days. Cool. So that brings us to the end of this session, and I want to announce the next webinar that's going to be on December 12th, and I'm going to bring you the latest offering from Microsoft, which is the managed Kubernetes service called AKS, or Azure Container Service. So I'm going to drill down into the architecture of ACS, how Microsoft has integrated that with rest of the Azure services, how do you go about deploying, and how do you set up your first managed cluster running on Azure? What are the differences between GKE and AKS? When should you use this? What are the pros and cons? So I'm going to cover all of that in the next month webinar. So stay tuned for that. It's going to be on December 12th at 9 a.m. PDT or 9:30 p.m. IST. So all of you will receive a follow-up direct mailer for you to sign up for this. Thanks once again for encouraging us by regularly attending. This is our 15th webinar, and I'm looking forward to continuing this series with many other exciting topics. So thanks once again, and all of you will receive the links to slides and the recorded video.